Hello everyone, welcome back. Professor Cameron here, and this is the part we're going to be working on today. Now, when we model this, what we're going to do is we're going to talk about Boolean operations and how that impacts our model. And then we're going to cover a few new techniques to model this part today. Now, whenever we model a piece, one thing that we want to do before we start modeling is we want to look at the model and sort of break it down into the simple shapes that compose this model. Right? The squares, the rectangles, the circles. Um, and the reason why we do this is because in SolidWorks, it's a lot easier to model and edit simple shapes like squares and circles than it is to modify uh, organic shapes, right? Shapes with a lot of geometry. So what we do is we add and subtract simple shapes from each other to create our object, right? And when we look at this, this is essentially comprised of two simple shapes, rectangles and circles, right? Rectangle for the main body, a couple of circles for this upright, and then a circle and another rectangle for this slot here. Now, the process of adding and subtracting simple shapes falls into the realm of Boolean operations. Like I was saying, constructive solid geometry, which is the modeling practice that we use to model, describes the solid model as a combination of basic 3D shapes. We call those 3D shapes primitives. Our primitives include shapes like cubes, cylinders, spheres, pyramids, cones, wedges, and torids, right? And we can make just about any object by adding and subtracting these shapes in various configurations. Now, our Boolean operations, as we know them, come in three different flavors. We have a Boolean union, a Boolean difference, and a Boolean intersection. Now, Boolean union and difference, we're very familiar with these. We've done these before, and I'll explain that in a second. Boolean intersection is something a little different. And we're going to model some parts using Boolean intersections a little bit later on in the course. But our Boolean union, this is pretty much what we do whenever we do an extrude boss base feature, right? We have our base solid, and then we extrude on a second solid, right? And we just merge those two parts together to create our final shape. Our Boolean difference, this is where we take our base shape and subtract from it another shape, creating our object. Now, a Boolean intersection. This is a little bit different. This is where we have our base shape A and our base shape B. But rather than adding B to A or subtracting B from A, what we do is we take the area in between, right? So this area here where they overlap, that's the area that we keep. And what this allows us to do in a Boolean intersection is to create some shapes that would be a little more difficult to do otherwise. In this example here, we're taking this sort of tombstone shape and this C shape, intersecting them to create this C clip here. Now, this is going to play a role a little bit later in the semester when we start creating parts for molds and stuff like that. This is where it really comes in handy. But these are our three basic operations. And like I said, we'll do an example of this a little bit later on in the semester. Now, when it comes time to model our shape, like I said, what we want to do is we want to do like we always do and break this down into its simple shapes. And like I said, this is going to consist of a rectangle and a cylinder, essentially. So let's go ahead and get started with this. What we're going to do is we're going to start this like we start all of our other parts. We're going to create a new part file. The first thing we always do whenever we create a new part file is we set our units. We're going to come down here to our bottom right-hand corner, and we're going to be working in millimeters today. Now, when we model, what we want to do is we want to start with sort of our base shape. And for us, that's going to be that large rectangle. So on our left-hand side, we're going to select our top plane and create a new sketch on that top plane. Now, depending on how you want to model your part, you may want to position your origin in different locations. What we're going to do is grab our corner rectangle, and we're just going to draw our rectangle somewhere out in free space, right like this. What I want in this is to be able to use my origin later on to position that large circle. Now, I want that large circle to overlap right like this, and we're going to draw this later on. So what I'm going to do is I'm going to position my origin so that it's in the midpoint of this line. The way we do that is by adding a relation. What we're going to do is we're going to press and hold down our control key. We're going to click on the origin, and then we're going to click on this line. On our left-hand side, we're going to select the midpoint relation. And that's going to move our square right to that origin. From here, we can go ahead and dimension this like we normally do. We're going to dimension this so that it has an overall length of 75 and an overall height of 50. Right like that. Now, like always, this is just a flat 2D object until we extrude this. So we're going to go to our Features tab and select Extruded Boss Base. And we're going to extrude this to a height of 15 millimeters, 15, and select OK. Right like that. So once we have our base done, what we're going to do is we're going to add on the rest of it. Now, the next step that we're going to do is going to add on this cylinder here. Now, to do this, we're essentially going to repeat the same steps that we did a second ago. We are going to select our top plane and create a new sketch on it. Now, like I said in our last step, we're going to draw our circle right around that origin. So we're going to come down here, grab our circle tool, put it right on the origin, and then we're not going to set a depth for this or a height for this. What we're going to do is we're going to draw this right to this corner. Since we defined the height of this box in our previous step at 50, this is going to have a diameter of 50 now. And we don't have to set that. This should be fully defined. Right like that. Now this exists on the bottom of our sketch. And what we're going to do is we're going to extrude this up through our model. We're going to go to Features, Extrude Boss Base, and we're going to extrude this to a height of 40. Now you can see here what it's doing is it's taking the cylinder and extruding it through this square. And this is an example of our Boolean union. Now, when we model like this, it's perfectly acceptable modeling method. One thing we want to check is to make sure merge results right here is checked. What that's going to do is it's going to take this solid and merge them together and treat it as one. I'll show you the effects if we leave this unchecked. But right now we can go ahead and select OK. Right like that. Now, like I said, I left merge results checked for that. If we go ahead and check our mass properties, it's giving us right now a mass of 120 grams. Now, if I go back and I turn merge results off, and I check my mass properties again, it's going to be significantly higher, right? Now it's 130, because what it's doing is in this area where the two solids cross, it's counting this area twice, once for the rectangle and once for the cylinder. This is a common issue that arises. A lot of times if you're modeling and your mass is higher than you expected it to be, and you checked all your units and everything is correct, check and make sure that merge results is checked. So that way it's not counting for this mass here twice. So like I said, we want that checked on most of the extrusions that we're going to do. A little bit later, we'll turn that off. But for now, we can go ahead and select OK. And that looks pretty good. Once we have that, we're going to go ahead and cut a hole through the center of this. To do that, we're going to select our top surface and create a sketch. Now our origin pops up in the center of this cylinder, which is good because all we have to do is grab our circle tool, put it right at the origin, and draw out a circle. We are going to set the diameter of this circle to 30. And then to cut this out, we're going to use our Features tab and Extrude Cut. Now what it's doing here is it's taking this cylinder of material and removing it from our base shape. This is an example of a Boolean subtraction or a Boolean difference. So we've got this here. What we're going to do is we're going to set our end condition to through all. It's going to take that shape, cut it all the way through our part, regardless of the depth, and we can select OK. Right like that. Now would be a good time to save this model if you have not done so already. What we're going to do now is we're going to cut a hole right here. To make this slot, what we're going to do is we're going to cut the hole first, and then we're going to cut a rectangle to join it. Now to cut this hole, we could just draw a sketch and cut a hole that way, or we can use the Hole Wizard tool. The Hole Wizard tool is a whole suite of tools that make creating complex and threaded holes a little bit easier for us. To access that, we're going to go to our Features tab and select Hole Wizard. What we have to do first is tell SolidWorks where we want this hole to appear. We're going to select this tab here, Position. What it's asking us to do is to select a surface that we want to put the hole on. We're going to select this top surface right here. And then it's going to give us this little hole marker. We can just put this anywhere on this surface. What we're going to do is we're going to smart dimension this right now, because right now we can drag this around, this little hole marker. So we're going to grab smart dimension. We're going to select this top edge of our part and this little point where our hole is. We are going to set that to 25. And then we're going to do the same thing to the front here. We're going to select this front edge and then this hole marker. And we're going to set that to a distance of 30. Now we can go back to Type under our Hole Wizard tool. All we're going to do for this is just drill a straight hole all the way through our part. Now if we look here, these are our different hole options. And like I said, this is really good for creating countersunk and counterbore holes to fit screw heads or threaded holes. What we're going to do is we're going to select the third option here, just straight hole. Under standard, we're going to select ANSI metric. Under type, dowel hole is fine. Under hole size, we're going to set that to 20 millimeters. And then end condition is going to be through all. Once we've done that, we can select OK. And that's going to show up here. Sorry. That should be 20 millimeters. And on your left here, it will show up as 20 millimeter dowel hole. So that looks pretty good. Now to finish this slot right here, what we're going to do is we're going to cut a groove, a rectangular groove from the front surface, and it's going to intersect with that hole. So what we can do is we can select this front surface here and create a sketch on it. We're going to grab our corner rectangle tool. We're going to click on this bottom edge here and then just drag a rectangle up to the top right here. We're going to smart dimension the width of this rectangle to be the width of our hole. It's going to be 20. And now we have to position it left and right. What we're going to do is grab our smart dimension tool, dimension from this line right here to this line right here. And we're going to set that to a distance of 15. So now we've got this rectangle positioned on the front. What we're going to do is have it cut up until it meets this hole. To do that, we're going to go to Features, Extruded Cut, and rather than using blind or through all, we're going to use up to next. And what that's going to do is it's going to take this rectangular cut and cut it up until it hits the next perpendicular surface. In this case, it's going to be this cylinder wall of the hole. Once we have that selected, we can go ahead and select OK. And that's going to cut that up and remove this bulk of material. And now our part is just about complete. The only thing we have left to do is to set our material. And for this, we're going to be using AISI 4340. It's a type of steel. We're going to come over to our material, edit materials, and 4340. Now you'll see two types of steel listed here for 4340. Annealed and normalized. The difference between these two is the heat treat that's been applied to them. And what that affects is your material properties like your strength, your tensive and compressive strength, and your yield strength. For what we're doing, it's not going to actually make a difference which material you choose because the density between these two is exactly the same. I'm going to choose normalized and apply. And now we have our finished model. So what we can do is we can go ahead and save this one last time. And then to get your material properties, you can go ahead and go to Evaluate and Mass Properties. If you guys have any questions on this model, please let me know. And as always, have a nice day.